Now, what is the Gauss theorem? A statement is the Gauss theorem states that surface integral, like this is an integral, and I put it here S. S means surface integral of electrostatic field, like E vector. E vector is electrostatic field produced by any source. Any source mean like that the source is a charge Q. Okay, because of this Q charge there is an electric field. So the surface integral of the electrostatic field E produced by any sources mean like Q, and our any closed surface, so I put it here closed. Okay, closed surface S like that here, this is a closed surface S, and there is a charge Q inside, and enclosing this surface is enclosing a volume V. Okay, then total electric flux. You know what's the meaning of the electric flux? Electric flux is E vector dot ds vector. Okay, E vector dot ds vector integral over the closed surface. This is electric flux. Then total electric flux over the closed surface is, and I am talking in vacuum, it is equals to, by the statement of the Gauss theorem, it is equals to 1 over epsilon naught times the charge. Okay, the charge contained inside the surface S. This Q charge is inside the surface S. So very simple. This total flux through the closed surface over volume V is 1 over epsilon naught times the charge enclosed. Now keep in mind one thing. The charge inside the S is maybe a point charges. This may be a point charges, or even maybe here the continuous charge distribution. Okay, and further the location of this Q is like that at here, or Q is at here, or Q is at here, does not affect the value of the left hand side. We have whatever the position of Q inside, no problem. The flux will be only 1 over epsilon naught times the charge enclosed. That's the Gauss theorem statement. Total flux is 1 upon epsilon naught times the charge enclosed. Okay. Now we are coming to the proof of the Gauss theorem. How we prove the Gauss theorem. Okay. Now this is our, the closed surface. It is exactly spherical in shape. And charge enclosed by this closed surface is Q, and let it is at the center. Okay, at here. Let we choose a point P here. What will be the direction of E because of the charge Q? How you find the direction of E? Very simple. You put it here a unit positive charge, and wherever the direction along which it moves, that will be the direction of E. If unit positive charge is here, this is plus q charge. Plus q will repel this charge along this direction. So this is E direction. And moreover, direction of the area, we consider this surface area. Okay, let we consider this surface element. For this surface element, a small surface element, the area of this ds vector, it is also along the same direction. We consider a very small surface element ds. Now, by the definition of E, electrical strength or electrical intensity at point P in vacuum, okay, we are thinking that our charge is in vacuum or it is in a free space. Now, first of all, constant, its value is 9 into 10 raised to power 9. Okay, then the source charge is q, and upon distance from here to that point P, which is r square. R is taken in magnitude here. Now direction of this E, it is along this side. This is r cap. Okay. Now we consider what is the flux of what is the flux which is attached with this ds element. Okay, and moreover, area is also vector quantity. So ds vector is equals to the magnitude ds and direction. For direction we put it here a unit vector n cap. N is a unit vector. It is also along the radius vector. N is also along the same direction, because area vector, it is a normal to the surface and pointing outward. So this is area vector. Now we write the electrical flux over the area element ds. What is the electrical flux for this area element? We write it here d phi. Okay, because this is a small flux which is attached with ds and is electric flux, so that's why E. So it is equals to, by definition of flux, it is equals to E vector dot ds vector. What is E vector? E vector is 1 over 4 pi epsilon naught q by r square, r cap, and ds and n cap. Now I cap dot I cap, dot product of I cap dot I cap, it is 1, because both are along the same direction. Similarly, r cap and n cap, both are along the same direction. So r cap dot n cap is 1. So d phi E, very simple, it becomes constant, okay, q by r square into ds. This is small electric flux. How we find total flux? Now finding the total flux, okay, phi E, I am integrating small flux like E vector dot ds. Okay, I am integrating it. E vector dot ds. E vector dot ds means small flux. And I just calculated was this value is constant q by r square into ds. Now integration of this for the surface. Right? Now what is the integral of ds over the whole surface? Whole surface, surface of the sphere. That becomes total surface area. What is total surface area? So flux becomes, these are the constants, 1 over 4 pi epsilon naught, q by r square, and integral of ds over the surface. So this is 4 pi r square. I considered the Gaussian surface as a spherical surface, that's why. Now 4 pi cancels, r square cancels. So electric flux becomes 1 upon epsilon naught times the charge enclosed. So I proved the Gauss theorem. Very simple.